the other thing that actually keeps me up at night is that the capability of the science and technology is not beyond the recognition of those individuals who see its potential value for warfare, intelligence, and national security purposes. And in all transparency, Eddie, as I must tell you, much of my own work has focused upon, if you will, the dual usability and the issues and problems that arise from the development of weaponized brain science. And that is a very, very rich, complex, and very often, I think, confusing subject. And it's also difficult because, again, given the sophistication and capability that these science and technological means and developments afford, there's a relative escalation and brinksmanship that can occur. And we have to be very, very wary of the profound potential of the brain sciences to be used in those ways that can be harmful to others, both individually and collectively.
Thank you for joining I Am Possible, which is India's first Future Tech Meets Sustainability podcast. Today, I'm delighted and honored to have with me Dr. James Giordano, who's the Chief of Neuroethics Studies Program, leads the sub-program in Military Medical Ethics, and co-director of the O'Neill Pellegrino program in Brain Science and Global Health Law and Policy in the Pellegrino Center for Clinical Bioethics, and is the professor in the departments of Neurology and Biochemistry at Georgetown University Medical Center. Professor Giordano serves as chair of the Neuroethics program of the IEEE Brain Project and an appointed member of the Neuroethics Legal and Social Issues Advisory Panel of the Defense Advanced Research Projects Agency DARPA, and has previously served as research fellow and task leader of the European Union Human Brain Project and as a senior science advisory fellow of the Strategic Multi-Layer Assessment Branch of the Joint Staff at the Pentagon. His ongoing research addresses the neurobiological basis of neuropsychiatric spectrum disorders and neuroethical issues arising in and from the development, use and misuse of neuroscientific techniques and neurotechnologies in medicine, public life, global health, and military applications. So, Dr. James, it's a complete pleasure and honor to have you on the podcast. There was quite a mouthful. So, why don't we start by explaining what the human brain is and how does it give rise to our five senses, or how does it construct reality?
Well, that's a wonderful question. We could spend hours and hours and days and months and years discussing that. So I've been doing brain science for about 40 years. And the short answer to your question is we really don't know. We really don't understand how the gray stuff of those cells in our head give rise to the great stuff of consciousness, thought, emotionality, and even really a lot of behavior. I mean, we understand that at this point, our construct of the brain is that it's an interconnected series of nodes and complicated networks that can change those network dynamics in very, very short time. So we're not thinking anymore, this area of the brain does this or does that, but how do different nodes and networks of the brain work in concert to be able to produce those functions that we refer to colloquially as mind? So although we don't necessarily understand it fully, through our contemporary use of scientific tools and technologies, we're gaining deeper insight to the patterns of the brain, the structures and nodes that are involved in these patterns of thought, emotionality, and action. And we're able to engage this sort of deeper correlation of structure and function through the technologies we have. And in so doing, I think there also becomes an increased capability to access and affect those structures and functions using the science and technology that's at our fingertips.
Can you unpack this a little further? When you say that we can kind of manipulate the structure and the function of the brain, and we have the science and technology, what is it that you're talking about? What do we have currently with which we can understand the structural function of and the capabilities of brain? What's the current knowledge that we have at this point in time?
Yeah, I mean, realistically, we have to understand that this field called neuroscience is really only about 45 years old. I mean, as a titular field, as a titled field. But I think that belies the reality that humans have been interested in brain structure and function for centuries. And as we've moved into the 20th century, the capability to harness our science into developing technologies that allow us to assess the living brain on a variety of levels, from the cellular level to the systemic level, and then to understand brain functions from the cellular level all the way to the socio-cultural levels, has become increasingly mature. So if we consider the contemporary palette, in other words, the contemporary workbench of the brain sciences, we can basically break this down into three categorical and interactive domains. We have those scientific techniques and technologies that we can use to assess the brain. Here we're talking about such things as various types of electroencephalographic recording, some that are exceedingly precise and specific, such as quantitative electroencephalography and magnetoencephalography, various forms of brain imaging. I think that such types of brain imaging, such as functional magnetic resonance imaging and various forms of tractographic tracing, coupled with genetic analyses and genomic analyses, biomarker analyses, have been able to create a relatively good picture on a variety of scales and levels of the structural functional correlations that exist in the brain, and have also created something, if you will, of a multiscalar brain map. Now, the next question is, what do we do with the map? Well, we do what we always do with maps. We go there. So the next category of scientific and technological tools are those that are used for intervention. And here we have such things as ever more sophisticated, capable, and precise drugs, and pharmaceutical developments that allow the drugs that we have to be able to access the brain far more specifically, and therefore enable lower doses of more potent drugs to be used with more precise effects. We also have the capability to stimulate the peripheral nervous system and the central nervous system through the use of neuromodulating devices that we can take on and off, in other words, wearables. And then we can get far more specific and precise, and we've developed implantable forms of neuromodulation, such as deep brain stimulation, and in its more sophisticated forms, types of indwelling neuromodulation, in other words, deep brain access through ever more non-invasive methods, so that the neurosurgical procedures that are currently utilized and necessary for deep brain stimulation may give way to increasingly less invasive approaches that allow us to get electrodes, sensors, transducers, and transmitters into the brain space without surgical intervention. The last domain of the science and technology that is very, very important to realizing what the brain sciences can do are what we call force multiplying or assistive technologies. And here we're talking about big data that allows us to utilize information on a variety of levels and scales from all of the different approaches within the neuroscience to be able to assemble, if you will, a more accurate informational depiction of the brain's structure on a number of levels, and the functions that those structures are involved on a number of levels as well. But in order to utilize these big data, it becomes important to engage certain forms of computational modeling and decision technologies. And here what we're seeing is the use of those machine learning and decision technologies and the increasing use of artificially intelligent systems, not only to interpret the data we're getting about the brain and from the brain, but also to yoke brains to computational systems in a paradigm referred to as brain computational interfacing. And taken together, this really creates, if you will, the working toolkit of the contemporary brain sciences.
Right. Yeah. So there's some exciting things happening in us being able to access what the human brain is, what it can do, and possibly maybe map it to a computer by actually understanding the language of the brain. Though we are very, very far away, but then there are some great minds around the world who are working towards, possibly understanding a human brain. The current innovation that we have is, we've kind of just about understanding a fly, and then maybe we trying to get into a mouse. There is some interesting innovation happening with DARPA, and you being part of DARPA, the N3 program, which had 6 startups, and I had the privilege of having 2 of them on the podcast, Xerox Sparks and Batel, and you are also part of the Human Brain Project or European Union. So could you shine light on some of the cutting edge innovation when it comes to neurotech?
Sure. I mean, I think you mentioned what I consider to be one of the most exciting projects in current neurotechnology, which is the DARPA N3 project. I mean, essentially, the idea is what's communicated in the title of that project: next generation non-invasive neuromodulation. The idea here is to utilize exceedingly small scale devices that are capable of both sensing the micro and macro environment of the brain and transmitting to that micro and macro environment, utilizing implantable devices, essentially nanoscalar transmitters and sensors, that can be implanted within the brain with minimally invasive or non-invasive means. In other words, providing this material for these sensors that can be injected into the bloodstream, inhaled, ingested, and then guided into the brain space in a very precise, vast array of sensing and transmitting electrodes that can be accessed remotely, which then allows remote capability to read from the living brain and interpret, if you will, the brain's language of communication utilizing decision technologies, computational algorithms, and AI, but also to write into the living brain, utilizing, if you will, remote sensing and transmitting capability that is able to translate across scales from the meso and macro level all the way down to the nanoscale to be able to modulate the node network activity in the brain on a variety of levels, from the very, very local to the almost systemic. And in that way, be able to both read information from the brain's processes of cognition, emotions, and the decisions that ultimately guide behaviors, and then affect those cognitions, emotions, and behaviors. At the same time that is incredibly exciting in terms of its provocativity of the way such technology might be used for biomedical approaches, it absolutely opens a Pandora's jar of what could be seen as capricious, contentious, or even nefarious uses. And it does speak to the idea that in reality, what we're talking about here is, quote, reading from the living brain. And if we consider the function of the living brain to be the mind, well, that's mind reading. And writing into the living brain, in other words, modulating the living brain remotely. And if we consider those functions once again to be mind, well, then axiomatically, that is mind control. So as your podcast with those individuals who are participatory in the N3 program have brought to light, I agree that it is very, very important, both in advance and during the development of these N3 projects, of which there are many, to both consider, address, and attempt to acknowledge and resolve those ethical, legal, and social issues that arise in and from the technology and its varied uses and perhaps misuses in and across the various range of application.
I don't think it's just neurotech. I think what's happening is that, almost all of the technologies, all of the frontier technologies, right from artificial intelligence to AR, VR, MR, to biotech, to quantum computing, all of these are accelerating in a space where, at least from my end, I don't see anybody having a concerted effort into understanding what could be those ethical, legal, or social impact if we do not guide it to a direction which is humanity first. All of these technologies extremely potential, and we are somehow just scratching the surface, but it could, maybe in the next few decades, it could go completely out of hand. But there is humongous benefits of technology, and technology has always been like that. I mean, through history, I think humanity wouldn't have been in the current space that we are at this point in time if not for technology. I wouldn't have had the privilege to have a conversation with you today. Internet has given us the privilege to connect with anybody and everybody, have conversations, and the phone, it's a pocket, small computer in a pocket. So, but these things are growing beyond our control. So we'll definitely get into the negatives part, but would you like to shine light on the benefits of this technology? If we nurture and nudge it in the right direction, what are the impact or transformation this technology could create on mankind?
Well, Eddie, let me first jump into a statement that you led off with, which I think is actually an incorrect statement. You said there really doesn't seem to be any group effort with regard to addressing or acknowledging the ethical, legal, and social issues that these technologies, taken singularly or in concert, may then evoke, arise, and/or sustain. I disagree very strongly, and I can tell you from my own professional experience that I've had the opportunity over the past 20 plus years of working with a number of groups worldwide that are very dedicated and focused upon evaluating the reality of what these techniques and technologies can do vis-a-vis the ethical, legal, and social issues that arise in and from the various uses and applications of these technologies, so as to essentially model and recognize, if you will, the possibility and problematic space. Yeah, as you very much acknowledged, these technologies are aimed at definable goods. I mean, realistically, no one who is working in the neurotechnology space has as their principal focus, let's use these things for reasons that are maleficent. In other words, that are bad, right? And it's important to understand that construct. So the low-hanging fruit, so to speak, is let's utilize these technologies in those ways that are important to understand human structure, function, the human condition, and the human predicament of injury, disease, changes that occur as a consequence of congenital and/or lifelong impacts, how humans interact with each other on a variety of levels. Well, clearly, that's oriented towards a definable set of goods. Right? In other words, they're benevolent, wanting to do good intentions and aims. But here, I think it's also very important to shine light upon what the philosopher Alistair McIntyre has called, well, what are the relative goods here? McIntyre's approach, I think, is important because he asks the question, if I may paraphrase, what good? Whose rationality? What justice? What I or my group or your group might think is a very, very good purpose, reason, goal, might not necessarily be shared in terms of its intent or its results by others. And it's that concept, the idea that striving to use these techniques and technologies for definable goods may create problems if those goods are not agreed upon, if there is not relative consensus that these goals, aims, and achievements actually represent viable goods on an idiosyncratic level. In other words, good for individuals who may be stakeholders, users, subjects, patients. But more than that, systemic goods. In other words, as these technologies spread in their uptake, in the relative public amenability to their engagement and to their distributed use, what is going to be the systemic effect, not only on individuals, but on groups, communities, populations, the new world order? So it becomes very important to understand that there are indeed dedicated groups, both within the actual organizations that are doing the science and external to those enterprises, enterprises that are trying very, very hard to be able to first keep their proverbial finger on the pulse of the pace, progress, and scope of the scientific and technological development, and at the same time trying to map, address, analyze, and mitigate, if not prevent, those ethical, legal, and social issues, questions, and problems, both as they are occurring and before they have occurred in some cases. So there is that dedication to understanding and recognizing that although the intent of using these scientific and technological developments is, as one might consider, good, understanding the relative nature of good and where goods can then produce burdens and harms, well, that's part of the paradigm. So there are a number of groups worldwide. I mean, obviously, the European Union Human Brain Project has a dedicated ethics group that examines those neuroscientific and technological progress going on in the EU. Here in the United States, there are a number of dedicated groups. I've had the pleasure of working with the Neuroethical, Legal, and Social Issues Advisory Panel at DARPA. I've had the pleasure and honor of chairing the Neuroethics project of the IEEE Brain Initiative. There's been some ongoing work at the Presidential Commission for the Study of Bioethical Issues. And there are a number of large-scale organizations, such as the International Neuroethics Society, the Neuroethics Network, that are specifically dedicated to addressing these very issues as they are occurring in real time.
Right. So maybe I was trying to hint at how much representation is there of like a diverse representation, because I possibly maybe I see that missing. Maybe you are, yes, there are ethical groups, but there will always be fringe elements because these technology is kind of getting out of hand. There's so many things, innovations, which is being built, which is, it's scary. So I hope that, that I'm sure there's groups who are having conversations and somehow can kind of, direct this advancement of technology in a direction which is human first. Would you like to address the benefits of these technology to mankind?
Yeah, sure. I mean, let's go back one step, because I think there are two things that you said that I'd like to comment on. First, that the technology is getting, quote, out of hand. In saying that the technology is getting out of hand would suggest that technology is already, quote, running away from the developers and users of the technology. That is a real acknowledged consideration and concern. One of the things that not only the developers of the science and technology, but those who are intimately involved with understanding the ethical, legal, and social issues that these technologies may give rise to, is a phenomenon referred to as runaway effects. Just as you've said, how can we actually control not only the development, but the patterns and diversities of uses on the global stage? That requires discourse. And the nature of the discourse very often is dialectic. In other words, it needs to be synthetic in its approach, and in some cases, syncretic. In other words, engaging various belief systems about what constitutes relative goods, relative burdens, and harms. Which then gets me to your other point, which was a stellar point, and I thank you for bringing that up. It's the notion of diversification. Let's face it, realistically, much of this science and technology that exists, or brain tech or neurotech, is the product of developed countries across the globe. And there are a number of them. Obviously, as we know, the United States and what I'll call its economic collaborators, the countries of the European Union, but also China, Japan, India, Australia, New Zealand, Argentina, Chile, etc. So what we're seeing is that a number of developed countries worldwide that have very distinct cultural orientations, and as a consequence, longstanding cultural philosophies and ethics, are participating in the brain sciences in terms of the development of the science and tech. Well, what that does is that sets the field, so to speak, of diversity in the ethical precepts that may guide the research and may also guide, govern, and dictate how the research is translated into a variety of practices in biomedicine, in public life, in business, and even in national security, intelligence, and defense applications. But along with that diversity in those groups that are committed, and we're talking billions of currency units of commitment to large-scale brain science and technology initiatives, one must also appreciate the diversity of the populations within those countries. They're not necessarily uniform. There are those that have access to the technology and science and those that may not. But then let's go one step further. If in fact this science and technology is the general province of developed countries, what about those countries who are developing? In those countries that are developing, engagement of the brain sciences, either intranationally or internationally, can create certain capacities within what we call the global bioeconomy. In other words, it offers countries some bioeconomic leverage at the proverbial bargaining table, and also creates particular capabilities within their social structures. So one of the things we're examining very, very closely is the interaction between developed countries' capability in the brain sciences and the desire, the need, and the use of these scientific and technological approaches in both developing countries and non-developed countries. This is much of the work, for example, of a number of my colleagues. Arlene Sales, for example, working with the European Union Human Brain Project. Professor Karen Herrera Ferra in Mexico, who's looking very closely at how the development of neuroscience and technology can be used to create certain leveraging, balancing, or lack of symmetries between developed and non-developed and developing nations, as well as within developing nations' population. Certainly, a lot of the work of Dr. Roland Benedicter from the EURAC Center in Bolzano in Europe has looked at the idea that neuroscience and technology are both contributory to and affected by what he refers to as the new global shift of the 21st century, both economic as well as sociocultural stage. And so a lot of what we're concerned with, I mean, specifically, this is a lot of the work that I'm engaged with one of my esteemed colleagues, Professor John Shook, has examined the need for a cosmopolitan approach to both the science and technology and who's doing what and what they're doing it for, and the ethical, legal, and social dynamics that arise in and from that diverse, multi-collective approach to the brain sciences. So that cosmopolitan approach also, if you will, recognizes the difficulties of creating these multinational, multicultural discourses, and I think brings the necessity of that work into stark relief.
Right, fair enough. I completely, double your views. I go back to the same question. As a neuroethical expert, what is it that excites you and what is it that scares you?
That's a great, wow, Eddie, that's a great question. So what excites me is the expanding capabilities of the brain sciences and its technologies to be able to be employed in those domains and applications to essentially better the human condition and to relieve the human predicament of injury, of disease, perhaps of changes in our capability as a consequence of living the lifespan. In other words, what we'd like to do is create a more viable health span in and across the ages of life. But, you know, here too, I mean, the point you raised earlier, Eddie, is a really good one. And it speaks back to our prior conversation a few minutes ago. Those things, although may be considered as definable goods, I mean, realistically represent a double-edged blade. This is a lot of the work of our colleague, Professor Dr. Nico Kohls in Coburg, Germany. And his primary focus is on the use of not just brain sciences, but emerging science and technology for health promotions. But this really brings to light your earlier point. How do we define health? What is health? What represents treatment? In other words, are we treating those things that we define as disease, dysfunction, or abnormality? When in fact, we're actually using the science and technology to define norms and standards of functionality, of ease, of wellness and health. So there's a bit of, if you will, circular performativity that we need to be aware of, and we need to monitor, guide, and direct very closely. Point number one. The second point is, well, then defining on the extent of those goods. In other words, if the idea here is to improve human flourishing and not just increase our survivability against the ravages of injury or disease, but to make our daily lives, quote, better. Well, in what ways? Cognitively, emotionally, behaviorally? What? We should make ourselves, quote, happier, pain-free, avoidant of suffering, more capable. Well, this obviously, if you will, calls the wolves out of the proverbial den, because it demands address, discussion, and at least proximate resolution of those questions about, well, really, how happy, how pain-free, how absent suffering, how capable, what represents viable treatment, and where does preventive intervention and health promotion really become optimization and enhancement? And then we have to ask the question, well, who's going to get the goodies? So what excites me about the brain sciences is their viability, potential, and value to be used in those ways to improve the human condition and lessen the human predicament of the burdens and, if you will, of the harms of injury and illness and those things that decrease our capability, our flourishing, and, if you will, our overall enjoyment of the quality of our lives, individually and systemically. But what scares me is that those very same capabilities of the brain sciences can be used to enforce relative goods in those ways that may be burdensome or harmful to others, that may render whole aspects of the population, collectives or cultures, relatively obsolete, and that do nothing more than create an ever-widening schism between the neurotechnologically enabled and the neurotechnologically deprived. In other words, widens the gap between the neurocapabilized haves and the have-nots. And then, of course, the other thing that actually keeps me up at night is that the capability of the science and technology is not beyond the recognition of those individuals who see its potential value for warfare, intelligence, and national security purposes. And in all transparency, Eddie, as I must tell you, much of my own work has focused upon, if you will, the dual usability and the issues and problems that arise from the development of weaponized brain science. And that is a very, very rich, complex, and very often, I think, confusing subject. And it's also difficult because, again, given the sophistication and capability that these science and technological means and developments afford, there's a relative escalation and brinksmanship that can occur. And we have to be very, very wary of the profound potential of the brain sciences to be used in those ways that can be harmful to others, both individually and collectively.
Right. Yeah. So I'm so excited that this technology can create augmentation of capabilities. You said there is so much that can be done. Diseases could go redundant. Pain could go redundant. But where is that level that we draw? And then you mentioned that weaponizing brain science. There'll always be fringe elements. There'll always be nations who would want to have an undue advantage with this technology. You hold a post of a gatekeeper of sorts, somebody who's got the keys. How responsible do you feel, because you could open the floodgate or close it? From someone who understands and is vested of the pros and cons of a technology which could completely upend mankind, if I had asked you to paint a picture or give us a view into your crystal ball capabilities, gazing capabilities of where humanity you think is going to go in the next couple of decades, what would you say?
First of all, I'd say thank you, because you've really overestimated my importance. I'm hardly the keeper of the keys. I am really just a cog in a very, very big wheel of a number of advisors on a variety of institutional and organizational levels, both within our government and its related enterprises here in the United States, and those various intergovernmental, interinstitutional activities in the brain sciences worldwide. I have the privilege of working with a number of individuals who serve advisory roles with me. But understand, those are advisory roles, and advisement only provides information about, if you will, those areas for which we need to be prepared, ready, and responsive. The decisions about how to engage or not engage the brain sciences occur on a variety of fairly high levels within the various hierarchies of government and the organizations responsible for a nation's security, intelligence, and defense. So if you ask me to look to the future I have to ask you about is, well, what future are we talking about? Because what's important for your listeners to understand is that in modeling the future, it's very critical to understand what vista of the future we need to appreciate. You know, I've worked with an absolutely stellar futurist, Dr. James Canton. And one of the things that Dr. Canton advocates is appropriating the future into distinct horizons of occurrence. And I agree. Dr. Joseph DeFranco, soon to be Dr. Joseph DeFranco, working in our group, has modeled that to some extent. So if we take a look at what these futures actually portend, if we look from the past 5 years to the next 5 years, we could and should view this as the zone or the vista of probability. In other words, there's a very high probability of those things that are being developed into becoming realized in a variety of different applications, in medicine, in social life, in business, in the military. As these things are realized, the next vista, in other words, 6 to 15 years in the future, that would be the vista of possibility, becomes more apparent. These possibilities are clarified. And in some cases, these possibilities become viable and accessible as achievable targets. And then as we meet those possibilities then become probabilities that allows us to look further, perhaps, that vista from 16 to 30 years, which is somewhat more difficult to model because realistically here, one of the things that happens is there tends to be a diffusion and dynamic multidimensional and multidirectional interaction of a variety of factors as science and technology are realized in various social conditions and contexts. And those social conditions and contexts in some way affect what science and technology is realized. This is what we call the horizon of potentiality. In other words, what are the potential capabilities, the potential uses for these sciences as they are probabilistically realized, as they are then aimed at particular possibilities, and then realistically, as those possibilities define what their potential applications are. So it's important to define what future we're looking at. In the 5-year space, clearly each and all of those things that are currently on the proverbial drawing board for research, development, and testing have a very, very high probability of being realized into some domain of application and use, whether in biomedicine, whether in public life, whether in the business realm, and or whether dual use within military and intelligence operations. But it also becomes important to assess how societies, both individually and collectively, will respond to these increasing capabilities of the brain sciences and other scientific and technological advantages to be able to affect social conduct, the social ambiance, social ecologies, culture, economics, which is why it becomes exceedingly important to understand the bioeconomy and the way neuroscience and technology interact with and affect that bioeconomy. And here, once again, a particular nod to some of the ongoing work of the aforementioned Joseph DeFranco and Dr. Maureen Riemann, who've done some great work in that area in plotting and examining the way the neurosciences and their technologies would affect the global bioeconomy over the next 5 to 15 to 20 years. So in looking to the future, I think it becomes important not necessarily to have a crystal ball, but to keep resharpening and re-refining the multiple facets upon one's lens to have a much more accurate view of what is occurring, what can occur, and then from those two positions, establish through discourse and dialectic what should be done to appropriately guide and govern the science in its various applications and uses.
Sometimes I feel that as humans, are we ready for something like this? Because the way the way technology is accelerating, we are looking at redefining things what we were okay with. For example, disease or death. What happens when we can possibly, age reverse? What happens when we can 3D print all of our human organs? What happens to a world where diseases get redundant? So I think these are questions which we as society need to ask, and are we ready for it? Because I think globally, almost everyone has got a veil of a religion is something which kind of takes them to a place where they do not question. We are living in a world where we need to constantly question things, and rather than saying that these things are bad, we need to understand that these are tools which has been capabilities given by whoever the creator is, if you want to say that there's a creator there, and leverage it for human benefit. I've been vested in virtual reality for quite some time, and even the most basic virtual reality experience today kind of tricks your motor cortex into believing that the virtual is real. There are these experiences called Ritchie's plank walk, where as soon as you put the headset on, the end user get into an elevator. He goes up on the top floor, and on the terrace there's a plank, and he's got to walk on the plank. And these experiences, that it's they show you at the mall or at your friend's house, and that nothing is real. That it's like not even realistic animation, but virtual reality does this in a weird way. Then there are people who are talking about full dive virtual reality. Full dive virtual reality is when a day. What are your views on that? Do you think a full dive virtual reality is possible?
It becomes, I think, important for the listeners to understand that our reality is what is presented to us through our neurological activity. We virtually filter the entirety of both our external and our internal experience through the various sensitivities and response parameters of our nervous system. It provides band-pass filtration in many ways. This is not only a cognitive neuroscientific question. It's also a long-standing philosophical question. It speaks to the older German idea of what is the thing unto itself. In other words, was ist der Ding an sich? So how do I perceive reality? Very simply, let me give you an example. So I'm nearsighted in one eye. So it becomes very important for me, if I want to see things clearly, I put on a pair of glasses. And now things change for me. So what is real? What does the world really look like? My impression of the world is dictated by my sense experience and then the perceptions and cognitions that I form from those sensory experiences, not only in present, but in the past. So one of the things that very effective virtual and artificial reality systems are able to do is to create a sensory experience that is profound enough in many of its characteristics to essentially engage the brain's processing to appreciate it as real in and across a number of different dimensionalities. So it's not just visual, it's auditory, it's not just visual and auditory, it may also be kinesthetic and proprioceptive. But understand that at this point, we're still talking about a device that you put on or take off, or a relative, if you will, chamber, some type of sit-in or ambient device, such as a simulator, that provides a multi-dimensional experience of a reality that is virtual. In other words, a created reality. And then the brain interprets that and creates its own reality from it. But let me be a little, if I could, speculative and provocative. Let's take some of the technologies that we were talking about earlier, these brain computational and brain machine interfaces. And let's say that one of the functions of those brain machine interfaces is to import information to the brain. What you essentially have is a conduit to create a virtual reality cerebrally. So the idea of modifying or modulating brain activity in a directed way so as to create a brain interpretation of reality is not far off. I mean, that's essentially current to next generation possibility of what these brain computational and brain interfaces could achieve. How would these things be employed? Well, in a number of different ways. I mean, probably the most benign would be for some form of entertainment or some form of lifestyle orientation, to be able to create relative virtual realities by direct brain stimulation. But then, of course, we take that steps further and further and further. Now, on the beneficial side, one could argue, as we and other research groups around the world have, that this technology may offer profound possibilities for individuals who are brain injured or neurologically injured to have a fuller, more granular and richer experience of the world, if not afford them the capability for direct reciprocal interaction so that they can then experience and express their subjectivity. But that exact same fact, that exact same reality, also has the potential for being highly manipulative, creating, if you will, artificial realities by being able to directly and perhaps remotely affect the way the brain is modulated and manipulated so as to, in this way, control individuals' senses, perceptions, cognitions, emotions, memories, and in that way, perhaps behaviors. So it's very, very important to understand the dual-edged capabilities of these, if you will, blades that are cutting through the current limitations of our science and technology, and recognize, again, their capacity to be very Januszian, in other words, two-faced. Yeah, we can use them for definable, quote, goods and benefits and to alleviate certain benefits, alleviate certain burdens. But I think at the same time, you have to recognize the potential for these things to be used in ways that can be highly, highly manipulative. And that is an ongoing discussion that requires considerable work, effort, and dedication.
Right. When you say that we'll come to a point where we can create artificial reality, manipulate the brain, which we can, you said, we do it today with transcranial devices or direct brain stimulation. Do you kind of question what reality is?
Yes, I do. You know, it's an older philosophical question that I think more and more is becoming the province of the cognitive neurosciences. In other words, what is real and what represents the construct of our own subjectivity? I mean, let's face it, our conscious experience is bounded by our own dispositions and biases, and then how we then utilize those dispositions and biases acquired through our lifespan and experiences to then direct our observations, our orientations, our decisions and actions. And so, yeah, I mean, I think that on both a philosophical level, as well as perhaps a practical and applied level, when considering the ramifications and manifestations of how the technology could be employed, becomes very important to reflect upon what is real, what are individuals' reality, and what is the interaction between individual subjectivity and the objective engagement of individuals' behaviors, actions, interactions with others, and the effect upon their environments.
What are your views on consciousness and free will? There was an experiment done called Libet Experiment.
Right, right.
Yeah. So what are your views on that?
Libet's work is very interesting. One of the things that Libet helped to bring to light was something referred to as the Bereitschaftspotenzial, which is a readiness potential. And I think it becomes important for folks to understand that there's a lot of neurological activity that occurs before even a thought, whether it's an intent or an idea, a reflection, an emotion, comes into sort of conscious awareness. In other words, there's a lot of neurological real estate that gets involved to be able to create the idea. Now, what that belies, I think, is whether or not the individual has free will, or are they some sort of biological automaton? And I don't necessarily think that's the exact right way of looking at it. I mean, yeah, if we take a look at various levels of brain activity, one could say that there's a lot of stuff that goes on both subconsciously as well as preconsciously that is necessary to then bubble into and affect our consciousness, inclusive of very, very deep neurological organizations that relate our prior experiences to the consequences of those experiences that then help to guide even just the way we observe the world. In other words, there's a sort of formativity that occurs within the brain to just create an idea, right? So there's a lot of neurological activity that goes into just creating an idea that then, quote, comes to mind, so to speak. The question of whether or not we have free will, I believe, and here very much support some of the work of many of my colleagues, not least of which Dr. William Casebeer, that it really is a question of the level that we examine this construct of free will. If we just look at the cellular level or even subcellular level, what we recognize is that there's a whole lot of neurological activity that needs to occur before a thought is realized subjectively, experientially, phenomenologically. And that would suggest that we are something of a biological automaton, right? But that's not how we interact. We don't interact with each other on the level of our cells interacting with cells. That's sort of a reduction to absurdity. Rather, we interact as systems engaged with and embedded in other systems. And if you will, the unit of interaction, orientation, and therefore responsibility is the entirety of the organism. In this case, human. So to simply say, well, my brain made me do it, or I have no free will because there are a sum total of integrative processes that occur before I even get a thought, which then renders me to be some type of neurobiological automaton, is incorrect. Because our level of interaction, our level of realization and recognition occurs at the organismal level, if I'm speaking biologically, and at the agent level, if I'm speaking more sociologically, anthropologically, and philosophically. So it becomes important to then, if you will, task responsibility on whether or not that agent, that actor, that organism's systems are functioning in such a way that allows them to guide and gate their own behaviors that arise from their various thoughts and the emotional dimension of those thoughts. That's a really fancy way of saying that, yeah, one could argue that we don't have free will, because if one takes this down to a reduction to absurdity, one can say that it's one's cells that dictate one's actions and intents. But I think without any without any denial, without any doubt. What we do have the capacity for is free won't. And here, a deep nod of homage once again to my colleague, Dr. William Casebeer. Let me explain why nervous systems are so elegant in their function. I mean, you have to think that any organism, I don't care whether it's a simple worm, a fly, a bee, whatever, each and all having their relative levels of, I think, profound complexity. But if you think of it, I mean, a nervous system is being continually bombarded with stimuli from its internal and external environment in dynamic interaction. At every single moment that we are alive, literally from birth to the grave, we are bombarded with information from not only our senses in terms of what's going on in the real time, but recollections from our past and underlying cognitions and what happens within our bodies. If we were attended to virtually all of it in real time, it would be functionally overwhelming. The beauty of a nervous system is that it essentially filters out that information, those stimuli and those responses that are not deemed, quote, critical or important to the overall function. They're integrated, and what happens as a process of serial, hierarchical, and multi-directional interactions within these cascades of nerve cells throughout our body, inclusive of our spinal cord and our brain, is that these are then filtered out. In some cases, they're filtered out to exist within our sub or pre-conscious. In other words, they're not becoming within our conscious awareness. And in other cases, although we may be conscious of them or could be conscious of them, we are selectively not attentive to them. But the way the nervous system does this is by essentially turning off or tuning down a variety of inputs. It functions much the way that a stereo receiver would work. In other words, when you, quote, dial in a station, what you're essentially doing is dialing every other station out. And that's exactly the way the nervous system works. It works upon these multiple organizations of filtration and pass filtration that then allow us to attend to certain cognitions and their respondent emotions to then guide our behaviors. So what we do have the capacity for in a functional, again, healthy, non-injured, diseased brain is the capacity for inhibition, both of certain cognitions and emotions and their outward expressions in terms of our expressed emotionality and our behaviors. So what we can say that is in fact binding in a way that takes us literally from an understanding of our neurobiology right up to an understanding of our capability, competence, and response, for example, in legal contexts, is that what brains do quite well is provide us with the capability for understanding the consequences of our expressions and actions, and the consequences in those ways, and responsibilities that go along with that. So one could, again, in some argue that based on some level, we might not have free will. But what I and many of my colleagues firmly believe as inarguable is that within a functional nervous system, it absolutely has the capacity for free won't. And that's something that is binding to the fact of being able to be responsible for the consequences of our cognitions, expressions, and actions. And as a consequence of that, certainly being held to that level of responsibility in a variety of socio-ethical and legal contexts.
Right. I've got two questions from my listeners, quick questions. His name is Varad Tote. His question is, can we mimic a human brain in a computer? Is it possible? If yes, how? And if no, what are the challenges?
No, I don't even think that's the goal. So the short answer is, that's a cool question. And I don't think the idea is to make a human brain in a computer. I think one of the goals is to make computers more brain-like in their function through neural network modeling and neural network functional capability. But it's not to make a human brain. I think that there are some ongoing efforts to create human-like or human responsible patterns of information processing and articulation in computational systems, so that there can be an interoperability with these computational systems with human users. In other words, where the brain and computer interface allows that interoperability in and across levels. And I think at the root maybe of your listener's question is it possible, therefore, to develop a system in a computer that is so neuro-like that it essentially takes on many of the characteristics of a neurally embodied system, inclusive of some level of awareness of itself and then some form of consciousness? The answer to those two latter questions, I believe, are yes. I do think it is not only possible, I think it is very probable that an increasingly sophisticated computational system, informational system, will develop some capacity for some level of subjectivity and self-awareness, even if it's just a question of understanding what is self and non-self. But then I think there are other implications once that set of functions are realized, and that's the whole discussion about whether or not autonomous or semi-autonomous machine systems and computational systems can develop beyond just a capacity for awareness, but an interiority that is an equivalent, if not something that is directly related or expressive of consciousness. And again, I mean, the short answer to that question is, I certainly think it's possible.
Right. Another question again from Varad Tote. Can we implant a chip in a brain which tracks every function of a body and brain and detects early signs or symptoms of diseases?
We've already done that.
Exactly.
Oh, without it, the short answer to that question is yes. It's not a question of tracking everything, but at this particular point, there's some selectivity and precision as to what types of brain and or bodily functions are being sensed and tracked that can then work as early indicators of either advancement of an existing disease process or vulnerability to a potential disease or some other mechanistic process that would then warrant intervention. We're already there.
Right. Thank you. Really appreciate you taking time and being part of the podcast. My last question to you. We are all trying to completely map our human brain, the structure and the function capabilities, and timelines of 40 years, 50 years, 100 years. What are your views? When do you think we will get to that? And how it will transform our world once we get to that goal?
That's a great question. I mean, I think the actual capability of mapping, in other words, structurally mapping the connectivities of the brain, is actually not that far off. I mean, based upon convergent technologies and scientific approaches, I mean, my estimate that a viable structural connectomics, I mean, is something we've already achieved on at least some levels. And now it's just a question of being more precise and being far more granular on what those connectomics actually are in and across various levels of precision and specificity. But structure does not necessarily indicate function. So the challenge, the opportunity here, is to utilize those structural connectomics to be able to develop a correlational functional connectomics or connectogram that then utilizes, for example, big data to be able to create a correlated repository of structural functional activities, engagements, and patterns that could be broad enough to be able to map not just structures, but functions in and across the individual diversity of human brains. Now, when do I see that happening? That's a great question. It really all depends upon not only the pace of individual aspects of science and technology, but the pace and extent of scientific convergence and cooperation and collaboration. So I'm not going to throw a time span there, but I think we'd see significant progress in creating functional mapping and functional connectomics that are applicable both to individuals and groups within the next 20 years.
Lovely. Thank you. It was a complete pleasure talking to you and getting your insight. I really hope that we come together and shape this future, because I believe once we are able to completely understand our brain, any and other technology will, not be able to stand up to it. So it's such an exciting space, and there is some really exciting things going on to it. So thank you for taking time and being part of the podcast. And to my listeners, if you like what you see in here, then please press the subscribe button. And until next time, see you guys. Thank you. Really appreciate it.
Thank you.